The graph of y equals f of x is shown below. Complete the table of values for the transformations of the key points a, b, c and d of y equals f of x. So let's just consider this key point here. A, -7, -4. That tells me that f of -7 is equal to -4. Now when I consider f of 2x, to get -7 in here, x has to be -3.5, or as a fraction, -7/2. So this one is going to be -7/2, -4. When I come to here, b, which is at -4, 2, that tells me that f of -4 is equal to 2. When I do it with the f of 2x, to end up with -4 in here, x has to be -2. So this one's going to be -2, 2. Now, to get 0, 2 times 0 is still 0, so this one is 0, -2, that's not going to change. And by the same sort of argument, this needs to be 3, 4. So if we draw that one now, we have -3.5 and -4. Now, -2 and 2 is here. 0, -2 is exactly in the same place. And then we have 3, 4. And that's going to look like that. So we're going to have a dashed, b dashed, c dashed is in the same place as c, and d dashed. And it should be clear from this one that all of the x coordinates are halved. We can see that it's moving in towards the y axis. And therefore a point that's actually on the y-axis, which has a distance of 0 from the y-axis, will not move under this transformation. Now, I've removed that one so that we get a nice clear picture with the second one, f of -x. So if we think again about a at -7, -4, that's telling us that f of -7 is -4. Now if we have f of -x, in order to get -7 inside the function, x itself has to be 7, and then we take the negative. So this one is going to be 7, -4. By the same argument, this one would be 4 and 2. This one won't change because -0 is 0. And then this one will be -6 and 4. So let's plot those points. So we've got 7, -4. And then we've got 4 and 2. And then 0 and -2. And then -6 and 4, like so. So if we draw that one, now what you should be able to see for the black one is that it's actually a reflection of the blue one in the y-axis. Look at the symmetry here. So this one gives us a reflection in the y-axis. So finally we want to describe each of the transformations. So this one is a dilation. Remember, we use the word dilation, not stretch. Scale factor was actually a half, all of the x-coordinates halved, and that was parallel to the x-axis, or we could say that it's a horizontal dilation scale factor, a half. This one is a dilation scale factor -1 parallel to the x-axis, but remember that that one is a reflection in the y-axis. And indeed, if we have a negative in here, there'll always be an element of reflection, and if it's something other than -1, there'll be dilation involved as well.